For joining us today. I'm Linda Briggs. I'm an editor here at TDWI, and I'll be your moderator. Our program today is how to mitigate analytics risk and complexity in a rapidly evolving data landscape. Our sponsor is Looker. And for our presentations today, first we'll hear from Fern Halper here at TDWI. After Fern speaks, we have a presentation from Joel McKelvey with Looker. Before I turn the stage over to Fern to get us started, just a few basics for the audience. Our webinar today will be an hour long. At the end of the speaker presentations, we're going to host a question and answer period. That's a great opportunity for you to get your questions answered around this topic. If you have a question at any time, go ahead and type it in there on your console and send it over. Again, we'll address those toward the end of the webinar. If you run into any issues during the event, there is a help area there below your slide window. You can click on that for assistance. If you're a Twitter user and you'd like to discuss this webinar on Twitter with fellow attendees, we certainly welcome that. Please include the hashtag TDWI in your tweets. Finally, for a copy of today's presentation, there's a line on your console. You can click here and download a PDF immediately. In addition, as always, we're recording today's event. We'll be emailing each of you a link to that archive so you can view the presentation again. Or please feel free to pass that link along to colleagues who may not have been able to make it today. Okay, once again, our program today is how to mitigate analytics risk and complexity in a rapidly evolving data landscape. Our first speaker is Fern Halper, who is a TDWI Vice President. She's also Senior Director of TDWI Research for Advanced Analytics. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology over the past 20 years. She's also co-author of several dummies books on cloud computing, the hybrid cloud, and big data. Fern focuses on advanced analytics, including predictive analytics, social media analysis, text analytics, cloud computing, and big data analytics approaches. She's been a partner at industry analyst firm Hurwitz & Associates and a lead analyst for Bell Labs. Her PhD is from Texas A&M University. So Fern, good to have you here. Let me turn the stage over to you.
Great. Thanks, Linda. Hi, everyone, and welcome to this webinar today about mitigating analytics risk and complexity in a rapidly evolving data landscape. Linda said it better than I, but we know that you're busy, and we really appreciate you taking the time out to be with us today. So here's what we're going to do. First, I'm going to talk about the evolving data landscape, and it will be no surprise that it's complex. So I'll talk about the imperative to reduce data complexity for analytics, since analytics is one of the top reasons for this complexity and one of the top use cases for data. So that's going to lead me to talk about the need for unification as a way to reduce analytics risk. And I'll talk about 4 different unification strategies that we're hearing a lot about at TDWI. And then we'll do some polling of our audience. I'll turn it back over to Linda to introduce Joel from Looker, and he'll talk about unification and Looker's perspective on that. All right, so let's talk about this evolving data landscape. So a major trend that we're seeing is that organizations are looking to digitally transform. So earlier this year, we did our annual survey on data and analytics. We do the survey every year. It's an annual survey, as I said. And in it, we try to understand what's happening with organizations, what they're thinking about, what their priorities are, and that sort of thing. And so in it, we asked respondents how important they thought it was to digitally transform. And you could see on this chart that over 90% of the survey respondents agreed that digital transformation is important to compete. And of course, there have been various waves of digital transformation. There's been the internet wave in the 90s, and then the e-commerce wave in the 2000s. But this newest wave is about the intelligent enterprise, and data and analytics are at the center of this new digital transformation wave. And so what we see happening is that there's actually this sea change occurring in data. So it's no longer simply about analyzing structured data in the data warehouse. Organizations are collecting diverse data from disparate sources. That's what this chart is trying to show. That data includes structured data, semi-structured data, and unstructured data. That's up there in that yellow bubble there. For instance, in that 2020 survey that I was just referencing, Close to 50% of respondents were collecting log data. 40% were already collecting text data. 35% were collecting other types of semi-structured data, and even close to 20% were collecting machine data, presumably for IoT or other types of use cases. So the data types are definitely expanding. And likewise, the number of data sources is expanding too for analytics. We see that organizations typically have a median, or they use a median of 10 different data sources to support their analytics. That may not be at the same time, but they have 10 different data sources. I mean, some obviously have hundreds or even thousands of data sources, and that data can be both internal and external to the company. And then, of course, if you look on the right bubble there, the data can be at different latencies as well. So in our audience, it seems like there are very few companies that are looking for data, say, in the millisecond level, that frequency at this point, but they're looking for real-time data in seconds, minutes, so there's definitely multiple frequencies. And as I said, a key driver for this is to support analytics. Excuse me. So organizations want data for different kinds of analytics. We see that a top priority is self-service analytics that might use data from multiple sources, both internal and external to a company. When we poll people, about various types of analytics, they'll say that self-service is at the top of their list. And that might be primarily structured data, but there's also an increase in demand for techniques like machine learning, and that could be used on all different types of data that include things like predicting customer churn or doing image classification on image types of data for diagnostic purposes. It might include text data to understand sentiment and intent. The list is wide and broad, and it's not just sort of necessarily using one type of data for your analysis. Oftentimes, organizations want to marry multiple kinds of data together for their analytics. For example, if they're analyzing text data, they might look at sentiment and then marry sentiment data, with billing history, for example, to see if that might, give them some indicator that a customer is at risk of churn. So there's definitely this sea change occurring in data in terms of the types, in terms of the sources, in terms of the latencies, obviously also in terms of the volume. We see on average customers have about, our audience has maybe like 10 terabytes of data. And so to support this analytics, organizations are trying to build a data foundation. So this chart comes from that same 2020 survey. And in it we asked, what data management and analytics tools does your organization currently use? And sorry, this chart is a little blurry, but trust me, that's what the question says. And you could see, maybe you can see at the top of the chart there, that the database management system and the data warehouse on premises still rule. So those are those big, long bars up there. And well over 50 to 60% of respondents are using those kinds of, that kind of way to deal with their data. But other platforms are popular too, like what we see, a cloud data warehouse. If you look further down on the list, there's something that says cloud data warehouse in the middle of the chart, as well as data lakes, and that's at about like 30%. So that's already moving into early mainstream adoption. And organizations are looking for more flexible and scalable ways to manage their data, and the cloud data warehouse often fits that bill. And then, they're also looking to collect and analyze those new data types I was talking about. And, they're looking to a cloud data warehouse or even a data lake. The lines are sometimes blur between them at this point for that. And then there's also emerging platforms like NoSQL databases. And you can see those further down on the list. So what we see is that organizations are often using multiple platforms. We refer to this as a multi-platform environment. And as I mentioned, the cloud is becoming more popular for data management. So here's a survey from 2019, and in it we asked, do you use a public cloud or a private cloud to manage your data? And you can see the top bar there is, we don't use the cloud to manage our data. That's about 35% of the respondents. And then down at the bottom, there's about 2% that don't know whether they use the cloud to manage their data or not. But then if you look, that's not even 40%. So over 60% of respondents are using the cloud. And that includes cloud data warehouses, cloud data platforms, data lakes on clouds, and so on. And as I said, users like the scalability, flexibility, and extensibility of the cloud. When they need the compute, they can spin up the resources, and then they can spin them down when they don't need them. And also, it's not just one cloud. What we see is a move to multi-cloud environments. So a multi-cloud environment, if you haven't heard the term, is an environment where organizations use multiple cloud providers to supply infrastructure, applications, and key business functions to the organization. It's basically a services model, I should say. So instead of a business using one vendor for everything, for cloud hosting or storage, in a or for a full application stack, in a multi-cloud configuration, they may use several different cloud providers. In our audience, we see actually more than half of respondents say they're either using a multi-cloud environment now or they plan to do so in the next year. And, what are the benefits? So that's the definition on the left. The benefits on the right, one of the biggest benefits that companies cite is more features and services. So the idea with the multi-cloud environment is to take advantage of the best features and services of each cloud provider. So for example, if we think about analytics, one cloud provider might have a better analytics capabilities, another might have better storage capabilities. So maybe you use one cloud provider, if it also has some external data that you think is useful that will help with your machine learning model. Maybe you use that cloud provider to build a machine learning model, but then, you bring that actual model over to, your primary cloud provider to actually deploy that for some sort of real-time scoring application. In other instances, the multi-cloud architectures can involve running different workloads on different clouds. The point is that the motivation for doing this is oftentimes around cost efficiency and features, if you're thinking about it. One other thing organizations like is they think that they don't have vendor lock-in. So many organizations cite the fact that a multi-cloud strategy enables them to avoid this vendor lock-in, but they can still get the different services that the major cloud providers offer, especially around things like security and analytics and application migration and application development services. There's also compliance is another reason why some organizations use multi-cloud, because they need to comply with certain regulations. So some organizations may need to have their cloud provider in certain regions based on their locations. So multi-cloud lets the organizations leverage the best cloud provider per region if that's an issue. And it may not just be about compliance in terms of localization. There may be reasons why you want to use, different cloud providers in different locations. So those are some of the reasons that organizations are using multi-cloud. Typically, when we ask how many cloud providers are you using, we see about 1 to 2 cloud providers, so probably some of the major cloud providers. We'll see some organizations saying they use more than 5 cloud providers, and that's probably getting, more complex. And there could be various reasons for that, but they may be good or they may not be good reasons. But the result of all of this, when I'm talking about the different data, the different platforms, using cloud, using multi-cloud, so the result of all of this is a complex environment. The environment has multiple data sources, which you see over there on the left. There's sensor data and database data, data from clouds, data, log data, all sorts of data that's both internal and external to the company. The data in the middle you could see is managed on multiple platforms, on premises, in the cloud, on multiple clouds. And the data is used by multiple personas, and that's over there on the right, like data scientists, data engineers, business analysts, and even business users. So multiple personas want to make use of all of that. The point is that as you start to advance on your analytics journey, you're going to be utilizing more data types. We see that very frequently, and that you're going to want to bring it together and, as I said, marry it, both the structured and the unstructured data, or even, multiple sources of structured data. You're going to want to bring all of that together for your analysis. And so organizations are looking to reduce some of the complexity to mitigate risk in analytics. If there's too much complex data coming, well, not that the data is complex, but the complexity of the sources, can lead organizations to think that, as they bring that data in, if they don't have a good way to do it, then they can't really trust it. They're not going to be able to be as productive as they want to be. So, there are reasons why they want to actually reduce this complexity and mitigate some of the risk around what happens, when data is spread out everywhere. And here are some of the challenges that organizations face with that complexity. So on the left are some of the challenges, and on the right are some of the levels of satisfaction that we're seeing in terms of organizations getting used to the data, getting access to the data that they need when they need it. So they're facing challenges with this complexity, and what we see as the top challenge for analytics is implementing the right data infrastructure for analytics. And interestingly, so obviously all of these data sources wanting to implement the right infrastructure. What's interesting is that challenge sort of comes above other challenges that respondents will typically cite, things like talent and data literacy and that sort of thing. And then second, they also cite that they need better tooling for data access as a top technical area for improvement. So the right infrastructure, the right way to access that data. And then in terms of clouds, we often see that data integration across cloud environments is a top challenge for organizations using or planning to use the cloud. So there's this theme in terms of satisfaction, is that there's room for improvement in terms of satisfaction for getting the data that they need when they need it. So for instance, my colleague Dave Stoddard recently did a best practices report, and in it he found that there was need for improvement in terms of data access. And you could see data scientists, data engineers, business and data analysts, app and service developers, in terms of the level of satisfaction. Data scientists, 42% of them, were satisfied, but if you look across this, you could see that less than 15% of all of these personas were very satisfied with how they're actually accessing data. So none of them are very satisfied. None of these groups are very satisfied. Some of them are somewhat satisfied, but they're not necessarily very satisfied. So definitely room for improvement there in terms of accessing the data. And how this translates, into analytics challenges is that you can think about this in terms of how someone might do an analysis. So in step one, the user focuses on the business question at hand. Let's say that is what customers are at risk of churn. So as part of that, the analyst is going to look at the analytics goals that map to this overall question. Perhaps the goal there for the analysis is to find out what high-value customers have been inactive. That could be a way to look at churn. And then that could be an indicator of churn, or maybe they even want to build a predictive model for churn. So then the analyst is going to ask, so that takes us down to step two. In step three, they're going to say, what data do I need? And they're going to think about, I need, maybe billing history or sales history, some demographic data, maybe some external data. Maybe I want to generate, some derived variables from the data. And you could see that in step four, this is where the analyst starts to get a headache because they ask, who owns this data? Can I get access to this data? Can I trust the data? How do I get it into my analytics tools? And then as the analyst starts to put the analysis together, he or she might see the same data in multiple places. So in step five, which is the best source? What source is accurate? Which is the right customer field? I mean, I'm sure all of you have experienced this type of thing. So you get the idea that the person goes from simply asking a question to often pulling their hair out over what should be a relatively straightforward analysis. And that problem also revolves around understanding, accessing, and trusting data. So that's why organizations are more often looking to unify data as a foundation for analytics. This may not be, some sort of unified set of data may not be where all of their data is for all of their needs, but they're looking to unify it to support a lot of analytics functions. So what I want to do, as I mentioned, is talk about 4 different approaches that we're seeing. Again, the idea is unification because there are risks with not unifying it. So think about it like time to insight gets longer because you're busy looking for data and making sure it's of high quality. Data sprawl can lead to lack of trust in data because no one's governing it and the tooling doesn't help to support it. You may not, if there's too much data sprawl and data is not unified in some way, you may not trust the output. And then you don't trust the output, that leads to lack of adoption. That is going to lead up to a lack of digital transformation, as I was mentioning in that first slide, which everyone thinks that they need in order to compete. So, data is definitely very important in data unification for that. So let's talk about these four different approaches that we're seeing. And of course, these aren't the only approaches, but we're hearing a lot of market discussion around these 4 approaches. The first one is an integrated stack. And while some organizations are satisfied with their traditional data warehouse that deals primarily with structured data and reporting and dashboarding, the vast majority of organizations we survey recognize the importance of modernizing their warehouse and analytics environment so that they can scale to meet dynamic data and analytics demands. And so what we're seeing is that vendors are forming partnerships for tight integration. So there may be a vendor that has a cloud data warehouse, another vendor with ETL functionality, another one with self-service functionality, and they're coming together to form these integrated stacks. So some of the pillars might include, this modern data warehouse, and then some of this newer data integration tooling, and these self-service analytics. With the data warehouse might be the centralized repository to service high-performance analytics needs at scale. Because remember, we're talking about lots of data. Data is extracted from the source system, and then it's loaded into the target system. And then these tools typically have numerous connectors. But the point is that the transformation is occurring in the target system, and these newer tools are pushing down the processing into the cloud itself because they can use the power of the cloud platform itself. So if you're looking for an integrated stack, then it's important to look at functionality and cost, right? Different providers have different price structures. For the cloud data warehouse, that it might include pricing per amount of time used or per query or per cluster. So your organization is going to need to understand how it's going to use the stack and determine what's going to work best for it. And as you look if you're going to go the stack route, it's going to be very helpful if the needed vendors have strong partnerships. So you want to make sure that they're technical partnerships rather than maybe just sales and marketing partnerships. So, for example, an ELT vendor may work with certain cloud data warehouse vendors at the technical level for pushdown, as I was mentioning. So you want to look to see if there's something like a reference architecture for multi-tool solutions. That's a good key to know if the analytics stack, is pretty tightly integrated. So that's one approach, is this integrated stack that we're seeing. Another approach is actually looking at platforms. So platforms, as we know, are a suite of related tools that are tightly integrated and interoperable. So typically there's a single GUI for a multi-tool environment, and different personas, can use that GUI. And what we're hearing a lot more about are cloud data platforms. So for instance, these are services-based, and they might combine like a data warehouse as a service, a data lake as a service, together with security and some analytics services. And the value here is that the tools are already integrated. You don't need to take this best of breed approach and try to integrate it all yourself. You can put the data into the platform for use for analytics. And the good news is then that you're operating off of a unified set of data for analytics. And, we typically see that organizations that become more advanced with analytics, this is sort of the mode that they want to follow. IT is oftentimes dealing with this. It's a common set, and everyone from the data scientist to the business user is using that same set. So that mitigates some of the risks that I was talking about in terms of trusting the data. It can help with faster time to insight once it's up and running. And in the case of the cloud, you can obviously use the scale of the cloud, so you can scale up and scale down. The platform also has shared development artifacts, so all the tools can use the same metadata and data sets and user profiles. Some of these platforms have collaborative functions as well. Of course, if you're going to use a platform approach, there may be some migration involved. Okay, so integrated stack platforms. A third approach that we're hearing a lot about is data fabrics. At TDWI, we define a data fabric as a way to seamlessly stitch together disparate data to provide a trusted view. It's not a new idea. Maybe some of it was popularized by Forrester when they were talking about big data fabrics. Back in 2014, one of our analysts, Philip Russum, he defined a data fabric as a unified view of data across multiple systems. So it's not just a view, he said, it was coupled with interfaces to provide a comprehensive view and enable access. So the fabric actually stitches together like a quilt, that stitches data together, if you can use that illustration in your mind. And there might be different fabrics, like a data warehouse fabric or an application fabric. The idea is seamless data access. So that's why organizations might be interested in data fabric, because theoretically, it makes the data easily available and brings together these siloed data sources in a trusted way. So if you think about bringing this data together seamlessly, that's going to help you support things like self-service and other types of analytics. Instead of spending time trying to stitch the data together, you're spending time actually doing the analysis, so you're getting faster time to insight. It's also, if there's a way to bring data together in a scalable infrastructure, this can also help to reduce sort of the shadow IT that I was alluding to before, that we know that organizations that succeed in analytics typically have IT manage the data infrastructure and build out trusted data infrastructure. And, they have a strong partnership with the business on this, and that sort of everyone's in it together. So one way to enable a data fabric is through data virtualization, which, we're hearing a lot about that also. And data virtualization provides abstraction and services layers. So essentially, it integrates heterogeneous and distributed data, all of that data of this multi-platform data architecture that I was talking about, without replicating it. And then it creates this single virtual data layer that sort of goes over these multiple data sources and supports multiple applications and users. The idea is that this data layer shields the users from the complexity of all of those data sources under the data layer. So there's these multiple data sources with this virtualization layer that can create these logical views in which the data looks consolidated, even though it hasn't been moved or physically altered. And often, if you want to get at that data then comes together in memory for you. So it's basically a platform type for modern data integration, and it provides the usual transformation functions, ETL, federation. A good data virtualization platform can support things like query planning. It might have some sort of business glossary or catalog to look for and understand, to help you look for and understand data. It should support things like self-service and that sort of thing. And so that data virtualization, some people look at it as an alternative to consolidating, their data in a platform or some other way, because they think about it by integrating data from disparate sources and locations and formats without replicating it, that they're creating this, basically this single virtual data layer that delivers unified data services, and that can unify the diversity of data. It just sits on top of wherever the data is, whether the data is on premises or in the cloud. And it can minimize, the argument goes, the disruption of migration and consolidation projects. And, like virtualization has been around for decades, but some of the software and hardware advances are giving data virtualization the speed and scale that's required of some of the service level agreements that are out there. Because, one of the negatives about virtualization was that people would say, it doesn't perform well, it doesn't perform well. So the vendors are trying to get past some of that, with some of the software and hardware advances. To do data virtualization is going to require good data governance be in place early in the process, because it's going to be important to know who owns the data, who can make modifications to the data, and so on. So that's another strategy that we're hearing about. And then I feel like I need to include some of the modern data catalogs to this list of approaches. It may not be exactly sort of in the same league, but I think it's important to note. So some vendors are providing catalogs that actually organize the data so it's searchable and it's findable. And the traditional definition of a data catalog is a searchable data directory or inventory that describes the data. But modern catalogs, these sort of next generation of catalogs, often contain new features, like they'll use machine learning to automate the processing of data or the interaction with it. Like they'll use maybe machine learning to parse and deduce credible metadata. Other tools can scan the whole data set, and they look for sensitive data because they understand the patterns, that would denote sensitive data, and then they tag that data appropriately so that you can use tag-based security. Some tools will automate the cleansing of data, and some automatically discover and suggest missing lineage. In addition to automation using machine learning, I have as the second bullet natural language query. Some of the tools will have that where you just ask you look for data sort of in a natural way. Some provide crowdsourcing and collaboration, so the tools, can help. You can use the tools to actually rate how good the data is. But the point is, in terms of the catalog, a few of the catalog vendors are actually enabling, you're looking at the catalog in the screen area, you're typing your search, and then behind the scenes, you're basically pulling this data out of wherever it sits through the catalog, and then you could put it into a sandbox if you want to use it for analytics. So you're able to connect to the data sources and, put them into a sandbox. And, in some way you're unifying the data and then pulling it out for analysis. And so companies in regulated industries might like that approach because the data can stay where it is and you just put it where you need it for analysis. During COVID-19, some organizations don't necessarily want to make, a big investment in new infrastructure, so they may look to this, as a way to help provide a unified view across different platforms. So that's why I felt like I needed to add it. All right, so those are 4 of the approaches. Let's do a poll question before I hand it over to Linda to introduce Joel. So I've been talking a lot about cloud platforms. So what cloud platform is your organization using for its data warehouse? So if, Linda, can you push the poll question? Yeah, please select all that apply. So we have AWS, Azure, Google, Snowflake, other, not using a cloud data warehouse at this time. So we've been talking about the fact that organizations are using a cloud data warehouse, that they may be using multiple clouds. So let's see where we stand on this. Okay, so let's see how So 25%, only 25% not using a cloud data warehouse at this time. So others looking like, yeah, because these numbers are adding up to more than 100%, using the big vendors, Google, AWS, Azure, Snowflake. They're using some other. So great. I'm glad to see that people are using cloud data warehouses. So with that, let me hand it over to Linda, who will introduce Joel. So Linda, back over to you.
Yeah, thanks, Fern. So let me remind the audience quickly to send your questions over for either speaker. We'll get to those after Joel's presentation, but I wanted to remind you we do welcome your questions and comments. On that note, please welcome Joel McKelvey. He's Director of Product Marketing for Looker. Joel has spent the past 20 years developing growth businesses in data for companies such as Cisco and Pure Storage. As Director of Product Marketing at Looker, he's responsible for researching and communicating details on how businesses use data to drive success. He's passionate about data and insights available to all audiences and frequently speaks on related topics at conferences around the globe. So welcome, Joel. Good to have you here.
Thanks. I really appreciate it. And thank you, Fern, so much for that great overview of all the different ways that people unify. I think one of the things that I'll add to this is...
I'm sorry. Go ahead, Joel.
Oh, sorry. Yeah, so one of the things that'll be a little bit different is I have some pretty strong opinions about some of these things. So I'm going to share with you my opinion and some of the things I've learned from some of our customers and some of our colleagues as they have been going through the process of modernizing their infrastructure and moving from data infrastructures they might have had for years or even decades into this sort of new technological environment that exists today with regards to, in particular, data warehouses and data lakes. So one of the things that Fern pointed out that I think is really key is just how complex infrastructure can be. I have a diagram here that is actually a pretty simplified version of how data moves from its creation to its consumption, from where it gets captured from one of these traditional systems or from new systems, from machine data that's being generated from sensors, all the way out to where what Fern called personas, how people use that data to actually do things. And traditionally these days, they mostly are going to do basic analysis around simple uses like a report or a dashboard, which can be very powerful and impactful. And in general, the data will be captured, ingested, staged, moved to an analysis tool or a data warehouse, then extracted so that your analytics tools can then work on a subset of that data, a data mart, or even something like a cube or an extract, some sort of aggregation. And as data moves from left to right, as it goes through the data lifecycle, there's some things that are really important and interesting. The data engineers around you will know about what happens to data as it flows. And one of those has to do with granularity as it moves across the data pipeline. In general, at every step in this process, and as in every step of a DAG or a data pipeline, what you're going to be doing is cleansing, aggregating, analyzing, and presenting materialized views of data as you go across, as you go down the pipeline. And what that results in is a reduction in granularity. The raw data is on the left, and some processed data is on the right. And that's good because traditionally what you've had to do is really present only the data people need. You've had to really worry about how quickly the data can be queried and analyzed. So you want to take a subset of that data. You have issues with data quality. You have issues with the auditability of data as it moves across the system. But there are some real challenges with granularity as well. If you want to explore data, to find new insights, to go beyond just receiving a report or a dashboard as a user, The fact that you're getting pre-processed data, extracted data, subsets of data, potentially stale data, can be very painful and reduces your ability to explore. And every step of this processing and manipulation of data across the pipeline takes time, and it can be complex, and it can be failure prone. So you end up with a system that can be unnecessarily complex and somewhat brittle. And when there are changes in the data that enters the system, or changes in the way that people want to consume the data, there has to be a lot of change in the middle and manipulation of the steps to make that possible. So we end up with very complicated systems around things like Apache Airflow, trying to make sure that the data is moving from left to right in an automated and scalable manner. But things have changed, and I think that that's really important for us to acknowledge. Now, we were just talking about cloud data warehousing. We were just talking about the move from on-prem to a private or public cloud, this hybrid cloud and multi-cloud approach. This is all being driven by real changes in the technology that have modified how data can be captured, processed, analyzed, and used. So let me talk you through a few of those that we see. The complexity of data in this staging and analysis phase has changed. There has been a sea change in the power and capabilities of what we would traditionally call a cloud data warehouse. A data lake is a whole set of semi-structured data where you put everything to stage it, to get it ready to then be processed and moved into an analytical database. But the new power of the cloud data warehouse has changed that. And so the reality here is there is a new construct available in the cloud that is both a data warehouse where you can place raw data, and a data lake where you can place raw data, and a data warehouse where you can do high-speed analysis of that data, whether it's structured or semi-structured, very, very quickly, powerfully, and scalably. So what you see now is that one of those steps, the so-called staging step where you place things into a data lake, is really no longer necessary with modern technology. I've heard it called a lake house, which is not necessarily my favorite term, but this idea of the compression of the warehouse and lake into one entity is very real today. I was recently talking with a colleague at Sunrun, the solar services company, and they are able to essentially move all of their raw data out of their legacy systems and new systems where they capture data directly into their EDW with a minimal amount of transformation. So instead of an extract, transform, load, it's really an extract load with very minimal amounts of transformation in between the extraction and loading. Once that data is moved into the data warehouse, then they use some simple systems to do some data quality work once it's in the warehouse, using the power of the warehouse again right there. So they don't have to use some sort of third-party system to do the transformation. They do it right in the warehouse using the power of the warehouse. And they find that they only really need to transform roughly 20% of the data that they load in, and they can do it in batches without having to strain any systems or spend too much money. So that's a very interesting change that I think impacts all of us. The next one is a change in how analytic systems actually process and use that data. And what we're finding is that there's no longer a need to actually extract data as you go forward. A modern business intelligence system or a modern analytics system is capable of using the query engine that exists today in the data warehouse to process the data as it is and as it exists in the data warehouse without the need for extraction or aggregation. So what you can see here is that that relatively complex system, because of the advances in both data warehouse and analytic systems, can be compressed dramatically into something simpler. And I think that that's a really, I'm not going to belabor this point, but I think that this is a really important takeaway from this session, which is we know that we have to move from older systems to newer systems. We know that we need to modernize this process. And it can be a complex one because of the number of stages that currently exist. But we can use the technology as well. You can use the technology as well to simplify where it's going, to simplify how you move those legacy systems into a warehouse, and then you perform analysis on them. So that compression, both of the lake and the warehouse together, the reduction of the need to extract or aggregate data before analysis really makes this whole process faster, simpler, cheaper, more robust, less brittle, and can make a major difference. And this is why I believe that people are going to the cloud. Now, as a vendor, I have a strong opinion about which systems you should probably use to do that, of course. But I would like to point out something about how this change impacts us. Where before you saw about 80% of my slide was consumed with data pipeline. What happens when you simplify all of the systems that bring data to the user is that you can focus less on the infrastructure side of data delivery and more on the insight and experience side of data delivery. So you can go beyond trying to make sure that these reports and dashboards are what you need and instead add in some really innovative ways of getting data into the hands of users who might not otherwise have it, or it might be arriving stale to them today, or it might be arriving in an untrusted manner. Now you can focus more on the insights, less on the infrastructure, and really try and deliver data where it's going to make a difference to the business. And that's where the technology allows us to make major strategic impacts by really trying to make those decision-making better and more powerful. It also frees up that data to do new and more unique things around stuff like AI/ML and data science, and going into some more interesting, exciting, and innovative ways of using data to get better business outcomes. So the simplification of the process is a goal we should all be reaching for. There's new technology that provides us those benefits. And I think that this concept of moving from an infrastructure to an insight approach to data is really key to where we're going. So with that, I've got a bunch of resources for you here, and I'll wrap it up here so that we can get to some questions. But do feel free to go and check out Looker.com and find more information about our approach and our thoughts on things like data consolidation, how you unify, what that approach looks like, etc. So with that, I'll hand it back, and maybe we can get to some questions.
Yeah, great. Thank you, Joel. I'm going to leave your slide up for a minute so people can take a look at some of those links. But yeah, let's move into our question and answer period. I want to give you a break, Joel, and start with a question for Fern on governance. We have several in this venue, Fern, but this one is, how do you govern these sorts of complex environments that we've talked about today?
Sure. So I would start off by saying that data governance is a top challenge often cited by organizations. They know it's important. It can be hard to do. It takes some time, but it's important that it should be managed and governed holistically across all the platforms, whether they exist on premises, in the cloud. It's just important to be able to articulate, rules and policies and processes, for protecting sensitive data. I think there was a question about, leadership. How do you get leadership on board? Well, they're going to have to be on board for some aspects of governance, including, personally identifiable information, things like regulations such as GDPR and CCPA, and that starts to sort of build, I think, an awareness of governance. There are also, it's a lot about people and processes, but it's also a lot about technology, and not a lot about, but technology can, certainly help with some of the catalogs and whatnot, can really help to build trusted data. So it's a matter of who's responsible? Well, IT, can take the lead, but business also has to be involved in it. They need to be attending meetings. It needs to be a partnership. It needs to be a balance. It can take time to build that balance. There's a lot of issues involved, where IT is in charge of managing the data. The business is supporting governance. It's sort of a shared responsibility, because they bought into trusted data, and that they encourage IT around that. I think, in terms of tooling, besides catalogs, you also, if you're going to go across these multiple platforms, you're going to need to have some sort of visibility into those platforms, sort of a single pane of glass, across those platforms. Also, Joel was talking about another type of, way to go on that, where your data is in the cloud data warehouse. Some of the warehouse vendors, also have tools that can help with that. So it's a big question. It could take half a day, and we have a virtual summit coming up in the summer that will actually cover data governance. So I would encourage people with questions on that to attend that virtual summit also.
Yeah, really a huge topic. Okay, thank you, Fern. Let's go to a question that came in during the registration process. Good one for both speakers, but Joel, I'll let you take the first swing at this one. What impacts on the analytics landscape do you expect to see as data ownership is increasingly transferred to the customer and the democratization of data begins to take hold in the industry?
Well, that's an excellent question. Thanks. Well, boy, we could talk about this one forever as well, but
right.
I think it's important to know we talk about volume, variety, and velocity of data as it comes into the system. More data than ever, in more ways, coming in quicker than ever. And what we are seeing also is those same 3 V's, volume, variety, and velocity, on the data consumer or the user side. When you democratize, you have more people want more data faster, right? And in more and new and different ways. And so that is essentially the challenge that's going to face all of us. So how do you deal with data ownership? Much like the governance question, there is a problem of unification, centralization, and simplification. Data estates tend to be sprawling, not because anybody has made bad decisions, but because when you come in as a data person into a company, there's a lot of legacy systems, there's a lot of things sitting throughout your company in various places with various bits of data ownership. And centralization is one of the ways that we overcome that complexity. It takes time. It is an evolution, not a revolution, but putting the data in one place, whether that's virtually in one place or actually physically in one place, understanding who owns it, tracking it, and keeping in touch with the users is very, very key. I would also say that, my central thesis around simplification holds true here. The simpler it is, the easier it is to see who should own what data, because you can understand what's there and how to get your hands around it. So in general, what I would say, what happens in the analytics landscape is a requirement to simplify, a requirement to get data into the hands of the end user. The ownership changes into a centralized or unified repository where you can do a better job of tracking, auditing, and measuring what's coming and what's going, so you can both meet the changing supply and the changing demand for this data.
Yeah, that's good. Thanks, Joel. Fern, your thoughts on this one as well?
Oh, sure. So I certainly agree with what Joel is saying on the data side, that democratization, as I mentioned, is definitely leading to organizations needing unification, right? We see that self-service is a top priority for organizations on the analytics side, on the data side, integrating, sort of getting the right platform, as we saw, is important on the data side, and unification can help with that, especially as everything becomes more complex. On the analytics side, I think, an impact to the analytics landscape, and then all of the stuff that goes along with the data, trying to make sure you don't have shadow IT and, really having, that data governed for trusted analytics. On the analytics side, I think that the democratization is also fueling the need for data literacy, because what we see is that self-service may be at the top of the list of priorities for organizations, say in 2020 on the analytics front, but data literacy is number 3. So as you get more data into the hands of more users and more tools into the hands of more users, those users need to be data literate. Not only do they need to know how to use the tools, but they need to know how to critically think about data, how to ask questions, and whatnot for true democratization to occur.
Yeah, thank you. Let me go back to Joel with a question here. Joel, a lot of the work that goes into building a traditional enterprise data warehouse is around matching and tying data from various data sources using ELT or ETL. Doesn't this need to happen somewhere in the pipeline? I think I'm reading that question correctly.
No, I think you did, and it's an absolutely valid question. It's really important. There is a need for transformation of data in a lot of cases, right? And it's a thing that we are used to doing in a traditional ETL data pipeline as the data goes into the database. And one of the reasons that we're used to doing it there is because we're used to databases which are extremely scale constrained and performance constrained. Particular, sort of legacy on-prem databases needed transformed or aggregated data as the data entered the database so that the database could, frankly, stay afloat. This is the change to the cloud database. The cloud database is, well, I don't know if it's infinitely scalable, but if you can scale your data to larger than Amazon can handle, I'd like to have a conversation with you because that's a pretty big system, right? So this ability of these large systems to handle the data without transformation is different than it was even a few years ago. So, but that does not obviate the need for transformation, right? You still need to match and tie data together. You still need to understand those schemas. And there's really 2 places where we see it done in a, let's say it's the perfect system, because really what you see extract small amounts of transformation and then load, and then large amounts of transformation after load. So it's much more of an ELT type of a system. But with the companies that I've been working with, they're still only transforming a small amount of data as it exists in the EDW. So 20%, 25% of the data gets transformed. The rest is transformed on query. So it's transformed at the time of query by a modern analytics system. And so your transformation on query used to also be very painful because the systems that were running those transformations on query, who were running those queries, were, again, performance limited. I recall I was at a conference in New York a couple of years ago, and someone was talking about how they couldn't both run transform batch and queries at the same time, so they had to do other transforms when they told users they couldn't get to the data, right? Like it was very messy with these sort of on-prem systems. And so now with the scalability of a cloud database, you can transform on query without seeing those huge performance impacts. And so you keep the data as granular and as raw, as untransformed as possible until as late in the pipeline as you possibly can. And that is going to save you a lot of challenges throughout the pipeline. You'll be able to see where it's being transformed. You'll be able to make sure that you are providing the best, freshest data to the people who need to consume it. And it also means that you'll be able to make sure that the transformation is done only when you need it. So one of the scale problems, one of the cost problems with traditional ETL is you transform all the data you're going to move over. But you may not necessarily need all of that data transformed. So you'll be spending money, time, processing power, complexity on a thing that you may not necessarily need. So waiting until transforming when it's in the EDW because you know that you're going to need that transformation, or transform on query, is just one of the mechanisms of pushing transform as close to the user as possible as a strategy, and then reducing the total amount of transformation throughout the pipeline. So I hope that answers the question, but thank you, a really good one.
Yeah, that was a good question. Thank you, Joel. On that note, we're almost at top of the hour, so I want to thank our speakers today. That was Fern Halper with TDWI and Joel McKelvey joining us from Looker. Also, thank you again to Looker for sponsoring today's webinar. We very much appreciate that. I want to remind everyone that we recorded today's event, and we'll be emailing each of you a link to that archive. You can feel free to pass that along to colleagues if you'd like to do that. And finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, webinars, and information on business intelligence, analytics, and a host of related topics. I encourage everyone to tap into that expertise. It's all at tdwi.org. And on that note from all of us here today, thank you very much for attending.